Okay, we're live again. Welcome everybody to the Azure and AI Show. And we have a few new speakers with us here today. So we're hoping Ravi will join us. And he has a session on accelerating microservices SaaS delivery with a scalable Kubernetes platform. So hopefully he'll join us shortly. Then we have Harry, and he's doing a session on supply chain transformation, delivering cloud technologies. And then we have Awazan, she has a session, what reality happens when you call Azure Open AI, and 5 mistakes to avoid. So exciting stuff. So we're just going to kick off with Dan Ray there. He's got some stuff for us. 1 second now. So Dan, over to you. There you go.
See if I can get my first slide to play again.
Bienvenidos, gente. Me llamo Dan y mi abuelito nació en España. Y in 2025, visitó España y LinkedIn en Madrid, España. Y visitamos con Gabriel y Ana donde está LinkedIn Oficina. Y Cristina Herrero invitamos y MVP Summit visitamos a Cristina. Me alegra compartir con todos la nueva comunidad, el Microsoft Speakers Hub en español, que forma parte del ecosistema de Microsoft Speakers Hub y contribuyendo a su misión. Esta iniciativa nació después de más de un año de conversaciones y colaboración donde Gabriel, yo y varios administradores de MSH exploramos cómo podíamos expandir Microsoft Speakers Hub a nivel global y hacerlo más accesible para más personas. Me entusiasma apoyar a esta nueva comunidad con Gabriel como fundador y con mi apoyo y el apoyo de los actuales administradores de MSH. Este es verdaderamente un esfuerzo impulsado por la comunidad para hacer creerse MSH en todo el mundo. El objetivo es crear un espacio que dé visibilidad a nuevas voces, nuevo talento y nuevo contenido para los miembros hispanohables antes a trabajes de publicaciones, encuentros virtuales y charlas informales. Por supuesto, las publicaciones también pueden traducirse a otros idiomas si los colaboradores deciden ampliar su alcance. Con ganas de construir esto juntos.
So that's our announcement for the Microsoft Speakers Hub in Espanol.
Okay, very good. Well, it done the translation very good anyway, Dan. Came out in English very good.
Yeah,
You're on the-
Gabriel helped me with the Spanish, and then I just, as you can see, I'm not the best at pronunciation, but
You got there.
yeah, if you practice, no
Yeah.
practicar, no practico, no improvement, right? You don't get better.
How you doing, Ravi? You're first up on the list anyway. Can you hear us okay?
Yeah, I can hear you. How about
Yeah,
you?
So if you want to share your screen there for us.
Oh, yeah, sure. Just a minute.
So when you hit the thing down in the middle there with the cross on it,
Yeah.
it'll pop up share screen, and then you go share entire screen, and then click on the screen. Yeah. Somebody. Oh, yeah.
I don't know if you guys can
Yeah.
see.
There we have it. There we go. Perfect. So I'll just move you up on the screen there.
Let me know if I can get
Yeah.
started.
You're good to go. Yeah, I can see your screen perfect.
Yeah, thanks. Hi, everyone. So today I'm going to talk about, accelerating microservices SaaS delivery with a scalable Kubernetes platform. Nowadays everybody is looking for some AI presentation. So this is not mainly focused on AI, but it has some AI elements. So let's get to it, right? So somewhere or the other, everybody is working on some or the other SaaS product, right? So we all know the challenges here. So one of the things that I personally faced in the very beginning about 10 years ago when I was actually getting started on this was how to roll out new features in the production environment. So setting up a new cluster, deploying your services, and giving it to QA for them to run automations, manually testing, demoing, all those things kind of tend to be such a big burden, right? And that's when I kind of started, thinking about this challenge and problem. And I did some, a solution in my company, and I was, very interested to show it to you guys. It has been running from 6 years without any issues. It's very productive. So I'm going to share it with you guys today with more features in it and a lot more, a meaningful way for people to adapt, right? So let's go. First, let us understand the bottlenecks and issues, right? So the biggest problem that I personally faced and is like the delivery of the feature is delayed because of all the development setup and setting up the cluster and whatnot, and on top of it the cost for the infrastructure, right? So it's a feature, maybe a couple of people are looking into it, maybe you're running one job to do some automation tests, but you're still using the whole bunch of EC2 instances or all the things that you're using in AWS or Azure, right? And that's gonna cost you, right? You're not efficiently using all of it. You don't really need a cluster to test a bunch of services, microservices, right? So and also it's a burden for DevOps to maintain running those jobs, and doing all the builds, right? And at the end of the day, it's like just to test a few features, you end up doing a lot of things. So we have canary builds for that people been using. I'll talk about that as well, right? So traditional architecture is somewhat like this. Like you have a feature branch, you deploy a whole bunch of services with the databases and everything, and you replicate all of it for another feature branch, and that's just going to be high cost, right? So let's talk about the canary builds, because I know a lot of people use it, but it's designed for production rollouts, not for development, right? So that's not the main purpose of it. And because you only have one canary build, so everybody tries to deploy in the same canary, and they will have conflicts. They'll try to resolve, and there will be conflicting features. So there is a discussion. There is just kind of waste of time there, right? And then complications with stateful sets we just discussed, and there is limited isolation between the shared clusters. So the better alternative is like a, a very namespace based smart isolation for any number of feature branches. So we'll talk about that a little. So I'm calling it like SDDP, but just a too big mouthful to say it's a scalable development deployment platform. But the idea is enabling feature level deployments, right? A feature level deployment. So meaning one single feature, you deploy that only for a certain number of services that you have changes in, right? And using the rest of the services from the baseline, which is probably your main branch builds, right? Or production builds. Uh, so you use the namespace for isolation, you use dynamic ingress routing, and you use feature-specific services alongside the production components, right? So the architecture shifts dramatically, and in this, and it reduces the operational overhead because you're not creating a new cluster, right? And your delivery will be very fast. So I have a hands-on demo I can show you guys, so you will see how fast it is. Right? So then let's talk about, so the platform architecture is basically, it's nothing new. It's the same existing architecture that you're going to use, like Kubernetes. You could use your CI/CD pipeline, and you possibly going to use a portal or some other way for you to interface this. The orchestration of creating these shared clusters, and that is what I'm calling like this web portal, right? Along with some of the services that it has, it will create these dynamic rules. So after the setup, right? So this is how it's going to look. So you have a shared baseline cluster with all the unchanged services and with the default namespace, right? And then you have modified services for a feature branch one, and you have modified services for feature branch two. You could have a default namespace, which whatever the namespace it is in, right? Doesn't matter. But the idea is this ingress rules, they know exactly which service traffic should be sent to which namespace the service. So that way, for example, you have a database service that is not changed for your feature branch. The traffic goes to that service in the shared baseline cluster. Right? So it starts with basic ingress changes, and then it grows as and when you introduce more and more services into it. So I will explain it to you the basics. We'll talk about the complexities later, right? So the basics of it, right? If you see, we can just set up a namespace isolation with network policies here, right? So we are actually saying this feature branch, my branch namespace, you're adding ingress rules for it, and you say, hey, you go to this service, otherwise the rest of it can go to the baseline services, right? So you have this web-based management portal, which actually kind of saves you a lot of time interfacing with it, so everybody can access it and kind of helps you. So you use your home Helm charts or whatever, right? And then your dynamic ingress routing, and make sure your CI/CD pipelines are integrated. So we will talk about, you can set it up for multi-tenancy as well. I think you can set up your secret management based on the feature branches as well, the network policies. Also, you can change and RBAC access as well, right? So you can analyze. So before that, right, I would like to show you guys a demo, and then we'll jump back to the slides. Okay, quickly. So what do we have here? So this is a portal that is running right now. So if I one sec. What was it? HTTP. Yeah. So it's available on my GitHub. You could access it. I'll share a link with you guys, right? So so the idea is, if you see this platform portal, you could see that I have created a bunch of demos already. So now you can see that this API timeout fix is a dev branch. It has a change in API and some front end. So, but the backend service, so I have actually 3 services in this SaaS, right? So the backend service is using the baseline. So if I go here, like I launch the site, so you can see that the front end is from API timeout fix. And if I call the backend service and also call the API service, you can see API service is actually using API timeout fix branch. And the backend service is using default branch. So like this, if you see, I have a user auth, right? So the same way, if I call all the services, right? So you can see that the default, they're using the backend default and API service like that. So let me just show you guys how long it takes to create one, right? So this is the branch name. So it has only front end change, right? So let's take a moment. So I'm deleting this. So while it is doing that, let me show you the ingress rules. Okay, we have service discovery, ingress. So this is actually a Rancher desktop running on my Mac. It's going to be a lot more complicated than this, but it's good enough for our demo. So you can see the default branch, the baseline ingress rules are there. So any API calls to the slash is front end, back end is backend service, slash API goes to API service. That's good. But if your changes are for API timeout fix dev branch, the backend goes to a different backend, and backend goes to the default backend. But if you see the API and front end goes to API timeout fix branch, right? The same way feature auth. So the one we just created, dashboard v2, has changed. So it has only front end change, everything else is same. So let's see. So this is creating, it's just not done yet. Okay, so now it's ready. It's supposed to be ready. Now let's see. Okay, so you see that both the backend and API services using default, and the front end is using the UI change only, right? So that way you see how fast it can deploy, and you don't have to wait for a long time to procure a cluster, setting it up, doing all the things chores, and before you actually do something meaningful on it, right? So you can right away just set up in few seconds, 2 minutes, based on the complexity, and then start deploying. So this is like a very happy path demo I've shown you, right? I mean, it definitely gets complicated, right? It's not that easy as it seems, but you have to start somewhere. So later on, so what you could do is, for example, in the page that I was showing earlier, I am actually kind of picking and choosing what to deploy manually by checking the checkboxes. But in a complicated service, I don't think that's going to be the case, right? So what you would rather do is, collect all the PRs or changes that you have, diffs, and then find out the impact using the AI, start analyzing them, right? So now the AI is so powerful. Back then when I implemented, I mean, I didn't have that choice much, but now you have the option to analyze the changes, figure out if they're actually violating or creating some kind of stateful inconsistencies that you can figure out, and then you can replicate other services as well if you think they're going to be a conflict, even though you don't have a code change in them, right? So like that, you can figure out which services to replicate and which services can be shared, and create a configuration for ingress routing and other network policies and whatnot, right? So this is just a kind of a def. You can kind of figure out for every service whether to use or not. So you can analyze the changes. It's just some sample code. So now with the help of this, you can see that it is accelerating your provisioning your clusters, shared clusters, right? You can just see in the demo, it just took few seconds for me. You're optimizing the spending here. Obviously you have a big cluster, you're going to share it and use it, right? And you're not actually kind of wasting the expenditure here, because you're trying to reuse all the services. Even though some services are not at all used in feature branch, it might be used from the baseline, so that way you don't really waste any money deploying that, right? So it is definitely the most important part, though. I mean, cost is anyway, it's important, but I think most important is the speed of the development life cycle. That is definitely huge. So a small change can be rolled out quickly to production. So, and it's definitely improved collaboration, because you spin up a demo, somebody can go through the portal, figure out which demo they're looking for, and then start testing on it if it is available, right? Better utilization and faster fallback loops. So yeah, this is basically the patterns used here. I think you kind of got it, right? So there are deployment strategy recommendations I would recommend to people, that it's if you start everything from scratch on your SaaS deployment, it's going to be very difficult to do everything from the beginning, right? So what I would suggest is start with a pilot team testing 2 or 3 microservices in a shared cluster. The remaining will be duplicated, right? And then slowly pull in more and more services and make sure they're compatible with this platform, right? And slowly integrate CI/CD pipeline, so that when you have a successful build, it will automatically upgrade those, so that you don't have to manually go kind of do some upgrades, right? So that's gonna be annoying, right? So, and create this. I didn't have dashboard, but you can create dashboards for better visibility, understand what's going on, where's the cost, and what services are replicated more often. Is there something you can optimize in your AI analyzation of the changes, right? And then expand it to additional teams and pull in all the services you can, right? So yeah, so that's the demo mostly, and the presentation, right? So yeah, I hope you got enough out of this, and making you think again about how you can optimize your development process. I hope this is helpful to you. If you have any questions, you can uh, get back to me on my X or LinkedIn. And yeah, this is my GitHub, where you can see the HTTP source code. So yeah, that's about it. Thanks everyone.
Thanks, Ravi. Very good. Great presentation. Any questions for Ravi, anyone? And we don't have any in the chat, but we have the LinkedIn up. There we have Dan. Great demo, Ravi.
Yeah, it was great to see a little Kubernetes and other stuff in your demo. That was great.
Thanks.
And there's somebody else trying to join us, but their broadband seems to be down. So we'll hand it over to you, Harry, if you want to share your screen.
Sure. Thanks, Frank. Can you please confirm if you can see my screen?
There you go. We have it up on the screen there now. Yeah.
Okay, just a second. Okay, my session is not very technical like what Ravi did. My session is more on coming from a business background, like real-time challenges from an enterprise, from a supply chain perspective, and how cloud technologies have helped or are helping us to navigate through these challenges, and how we are trying to leverage the latest AI technologies to kind of benefit the organization and help the people doing the real job on the field. Having said that, I'm taking Oracle Cloud Fusion as it is on our landscape. But yeah, I mean, the concepts and it is same for any application suite that is available in the market in the supply chain collaboration area. So just because we are on the Fusion, I mean Oracle Cloud, so I'm taking this example and running through these details. But yeah, I mean,
Harry, just 1 second. Sorry for interrupting you. Are you showing a PowerPoint presentation? Because we don't see that.
I am actually sharing.
Yeah. No, we can see your screen, but we don't see the PowerPoint.
Oh, sorry. Why? Let me stop sharing and start sharing one more time.
Do it again there, yeah.
Yeah, we were seeing the StreamYard screen.
Yeah. So try it there again now.
Okay.
Good evening, Stephen.
Yeah, good evening. Good evening, everyone.
Hey.
Good evening.
How about now, Frank? Is it the same?
No, we can't see your screen.
No.
Oops. Okay.
So when you go share screen, share entire screen.
Yeah,
click on the panel on the left then.
Okay. I think I did that. Let me try one more time. I stopped and
Okay,
I'm trying one more time.
checking out. Right, we can see. Yeah, we can see it now. Yeah.
Yeah, good.
Yeah.
Okay, perfect. So Oracle Cloud Fusion, it's a comprehensive suite. What we have on our landscape, it's a cloud-based enterprise application designed to streamline and integrate organizational processes across various supply chain streams, including procurement, logistics, planning, and order management. The big advantage with these cloud solutions, what we have noticed coming from a on-premise environment, is like they deliver a unified data model and real-time visibility, and also the platform's modular architecture. They allow progressive adoption, and also it comes with all the latest and greatest technologies available very fast, rather than the on-premise, which needs major upgrades every time when there's a new technology innovation happening. We are always technology ready, from a cloud perspective when we are on the cloud applications.
Ari, we're seeing the PowerPoint presentation mode, not the full screen. If you click on the display settings in the upper, and then just swap monitors.
But that one is actually grayed out for me.
Okay.
Let me see, maybe.
You can probably set it
Are
up.
you using like a external screen?
No, this just my on the laptop. I didn't even extend it to my monitors because I knew that's causing some problems. Okay.
Maybe probably just stop and then stop the slide and then make it as presentation mode.
Okay.
Yeah, in the slideshow menu, when you're not presenting,
Mhm.
you should be able to tell it to not use presenter view.
Yeah, because we're seeing
Or yeah, try hide presenter view, see if that works.
Okay.
Yeah.
There, perfect.
Is that good now?
Yeah.
Yeah.
Perfect.
Okay.
Sorry
Perfect.
for interrupting.
Okay. So why the transformation? What were the challenges that required a transformation of our supply chain? So we deal with thousands of suppliers onboarding and managing, collaborating on a monthly basis. And it required a lot of efforts from the internal teams, the teams managing the suppliers, monitoring, managing, collaborating. And management's perspective is we need to make suppliers as part of this collaboration, not just the end users, kind of like just provide documentation and then wait for our company to come back. So that's the whole objective, to bring them into the collaboration suite. And also, whenever we try to onboard a supplier, it is taking significant amount of time and delays because of the manual paperwork submissions, back and forth phone calls. And also, when we started this supply chain cloud initiative, those are some of the crucial objectives to cut down these overheads, to cut down these delays in the onboarding, to cut down the lot of paperwork. So this has helped us significantly in the transformation process. And also, especially in the areas of suppliers, any changes to suppliers are audit attractive. Like, auditors have a lot of questions around these changes. And when we were on the manual or paperwork plus legacy ERP systems, so you do have the changes and you try to maintain all the documentation, but it is very challenging when the auditors ask a lot of questions on how, who did, who approved, and all. So that's where the workflows come into picture. When some auditors raise the questions, you have every change audited, every change audit completed in the system. It is easy to answer audit questions. And also scalability with all these new technologies like the AI and everything. And so many technologies, latest technologies coming up fast. So our environment needs to be ready for embracing these latest technologies. So we went with the cloud fusion landscape there. And what was from a enterprise side, some of the enterprise objectives are not just on the supply or collaboration side. They were also looking for an integration within various supply chain functions. Like, earlier, this is not just a supplier tool, okay, where you manage suppliers and then. So this is more collaborative, integrated along with a lot of procurement activities, contracts, agreements, pricing, inventory, order management, logistics, and all, bringing into one ecosystem basically. And on top of that, now data is crucial for everything. Okay, we're depending a lot on the external tools for all data analysis, but that requires a lot of data integration happening between various things. But now people want to see that impact straight away, and that's where even the embedded intelligence and analytics helped a lot when we moved into this space. And also, these systems are like, not just a device dependent, like, the same system, same application, you can see it on a mobile without any changes, without any on a tablet. It is ready to be fit onto a Mac, any monitor size. So these are all the new application features that was helping a lot with the mobility as well. So now start with the supplier qualification, one of the prime objectives of the whole program. So as we onboard and manage hundreds of suppliers every month, so some of those activities are creating new suppliers, collaborating with the existing suppliers, getting them registered, and maintaining their profiles by themselves. If there is any change to their bank account, let them go ahead instead of sending a large paperwork and then wait for our finance team to review it, get it approved, and again, it has to be updated. Call the supplier, inform them that it has been updated, and send it. So avoid all that. Like, now supplier can go into their profile, update. It goes through a series of workflow approvals, and then it's updated in the system within very short span of time instead of hours and sometimes days of activity. We go back to the architecture diagram in our landscape, where Oracle Cloud SQM is our supplier collaboration suite, and Oracle JD Edwards is our end ERP system, our core ERP system. So while onboarding a supplier, there are many pieces, many components that come into play. Okay, some of the crucial points we were manually having challenges with manual checks and balances is checking their tax identification numbers. Okay, supplier submits a bunch of documents and their W-9s and some insurance documents. It's a big packet that comes through, and going through that documents, because they're in different formats, they're in different years, so it was very challenging for the teams to understand that and go through the details and approve. Now, when they submit this through online, we have APIs developed and integrated with various third-party systems, like TinCheck is a IRS tax identification system. So as and when the supplier submits, even before it is approved, a back-end process actually does the TinCheck with the API, and then it comes up with a summary even before it goes to the first level of approval, saying that, hey, the TinCheck is successful, the details submitted by the supplier is matching with the IRS records. Same like Office of Foreign Assets Controller, OFAC. So it's a very regulated industry that you can't do business with every vendor across globe, and also you need to make sure that you are not doing business with sanctioned nations or some organizations. So if by mistake you miss that line, you cross that line, and you do any kind of business with these parties, then you are penalized heavily. So now OFAC check is also through an API. I mean, even before the first level of approval looks at the data, it clearly explains, okay, if there are any of the supplier listed on OFAC, it calls out all those details, like, hey, this supplier is listed as part of a nation that's on sanction list, or an organization. So just stay away from doing this business, right? Same with some suppliers who do business with us mandatorily requires a lot of insurance and compliance documentation. They need to go through that before they enter onto our manufacturing sites. So they submit this insurance and compliance documentation, but again, going through that pages and pages of documentation is taking time. Now, with the AI embedded into that, it goes through the documentation and comes up with a clear summary with what we really want to see out of that. Hey, this vendor is certified to perform like blasting operations. This vendor is hauler is certified to get into these quarries or mines, and these are the insurance details, like they are going to be valid until these dates. Same with bank accounts. Okay, bank accounts are very crucial. That when the supplier submits documentation, some of the times their names won't match with the accounts. The accounts are not existing. So now online bank account validation, they submit the details. It's already tightly integrated, and it looks for the details on one of the bank APIs, and it does the checks and balances behind the screen globally. So yeah, these are all the new features that helped our business partners to perform their day-to-day activities more efficiently and focus on critical activities rather than focusing on more documentation review jobs rather. And this is a flow or process flow diagram as part of any new supplier we onboard, how the registration is submitted by the requester, and then it goes through various and who receives the notifications for approvals, and who approves it, and if it is a certain supplier, how many levels of approvers has to approve, or if it is a hauler or a supplier performing on-site services, he needs to be approved by compliance team. They need to review this compliance documentation, whether it is certificate of insurance or whatever, all those documentation. And all the bank account and ACH information needs to be reviewed and approved by the finance team or the accounting team or AP team. So all these are configured such a way that you don't have to kind of monitor like whether this has been approved by all these parties or not. So at the end, the supplier is finally approved once all the parties does their job. Like, you go review in your space whether all the information is correct. There are a lot of automations behind the screen helping you to summarize the supplier profile, to summarize what they do, to summarize what their background checks are and all. So finally, all these parties, once they approve, the supplier is finally integrated into the core ERP system and ready for doing business with them. And these are the new AI agents and Oracle Cloud ecosystem holding. I mean, there are so many coming up every day as part of the new releases. We are still in the process of evaluating what helps us instead of trying to implement all the AI agents that are available on the cloud space today. We are going with cautiously embracing or cautiously, going live with those agents that are really helping us. For example, the supplier request summary is very helpful. You don't have to go through all the details one by one field. First level approver, before he approves, he has a summary now. Okay, this supplier is going to provide these parts and services, this services in these areas. Everything is summarized for him. So that helps him in quickly taking a decision and approving it on the mobile. Like, he doesn't have to go into the system, navigate through hundreds of screens, finally approving. Now everything is summarized and upfront. You can just hit a button on your email that completes approval process from your end. So that's the whole program was all about. We deal with close to 18,000 suppliers today, and it was even more. But when we went live, we kind of almost deduped 20 to 30% of the suppliers based on all these checks and balances, like, what the business they are doing, what are their tax IDs, and are there really duplicates in the legacy systems and all that. So now we are in a more stable state, and we are seeing the benefits of all the implementation and the efforts we did as part of this cloud initiative. I think that's pretty much from my side. Frank, any questions? I'd be happy to answer.
Thanks, Harry. Great presentation. Very clear. Very good.
Thank you.
And great to see all the new cloud technologies in there, and these expanding big time, isn't it? Anybody, any questions for Harry? No, you're all good, Harry. And we have the LinkedIn. If anybody else has any questions for Harry, you can stick it into the LinkedIn there, or our comments.
Thank you.
Okay. So over to you. Owazen.
Good evening, everyone.
Yeah,
My name is Oluwaseun Deborah Debayo. You can call me Deborah. So today I want to speak and we discuss about what really happens when we call an Azure Open API and the common mistakes we need to avoid. So this is just like a practical breakdown for we trainers, architects, builders, and I'm going to be using a system I'm currently working on. I call it NOSA as a case study. So I'm just trying to play around some of these tools to bring out something. And like an AI assistant e-learning environment. So I'm going to be using that as a case study. So currently I'm sharing my slide. Is that what we can see on the screen?
We can't see it yet. Can you just try and share it again?
Okay, so I'm just going to do that. Okay. Share screen.
If you uploaded them, they will show up under slides and PDFs.
We have it there now.
Perfect.
Yeah, there we go. We
Yeah.
can see yours.
So Can you? All right. Okay. Very well. All right. So, basically, most people think calling the Azure Open AI is just about sending prompts and getting a response, But in reality, based on my experience, because while working on that system, there were a lot of back and forth errors, issues, failures that I had to troubleshoot, and it actually gets me, sunk into the process to have more deep dive understanding. So it's a full cloud workflow involving the front end, the back end, the security layers, and the Azure enterprise grade as an entire safety pipeline. So it is beyond just, a call and response relationship. And when you use an Azure Open AI, your requests doesn't just go straight to the AI model. So we would think of the Azure Open AI like when you're trying to send a letter, like a mail, we're trying to send it through a very secure and well organized postal system. So that is just what the Azure Open AI operation flow looks like. Before the AI would give you an answer when you send a request, it would first have to pass through several protective and management steps inside the Microsoft ecosystem itself. And these steps would make sure that everything within the contents of the mail you enveloped is safe, it is controlled by the organization policies and regulations, and everything is working properly. I have okay, so I have just like a pictorial explanation here. So the first one, which is the one on the left, kind of relates with the layman understanding. So where we have the networking stage representing how letters are being delivered. So basically, it's just talking about how Azure AI handles our request, or I would say how the delivery man handles our email. So we'll think of it in that phase for us to grasp, some deep understanding about it. So the first phase, when we have the request traveling through the internet to reach Azure. So we look at it like a letter moving through the different postal routes. And then the second phase here, it checks for security. This is where the system would check that the request which we have made is safe, it is allowed by the organization policy, and it is coming from the right person. So in this phase, we can look at, the confidentiality, the integrity of that mail that we are trying to communicate across. Then the next phase is the governance stage, where it follows the rule. It ensures that the process of the request and granting the request actually follows the company policies, the privacy rules, and if there are any restrictions that are set by the organization. After this phase, it moves on to sending it to the right department. That is the orchestration level. Here, Azure will decide which AI model or service is best suited to handle our requests. And then it moves on to the compute stage, where it actually does the actual work. And this is where the AI model would finally process the request and generate a response. So at the safety level, it would also do like a double check of the response to be sure that it has actually provided the right response to the question. Most often times when we query any of those AI tools, maybe Copilot or ChatGPT, sometimes it gives us some weird response, and then we have to reprompt, we have to requery it, maybe by making sure that the keywords that really matter to our request are included in the request. Then it regenerates the response. So At the safety phase here, it will have to do a double check to be sure that, okay, our response or the response it has provided is actually what matches the request we made. Then finally, it delivers the final message only after passing all through those layers. And just as it is in a plain English, we have it in the technical concept on the right, where we have the architectural concept, which talks about the first stage of making the request. So the request can actually be made by a developer or through an application. So looking at the first architecture, which is just the non-technical, put it that way, or from the managerial aspect, we would agree that there is a lot that goes on in the internal system in the background when we call an Azure OpenAI. So it is not just a click and run operation. So I'll be explaining in the technical domain using the right diagram I have on the screen, which has the architecture concept and explains through the 7 layers as well: the developer application, the Azure OpenAI API, the Azure Cloud Infrastructure, the OpenAI LLM, the response processing, and finally, the client receives AI response. So how does this work? We all are familiar with, querying an environment using any kind of application. So the application in this phase could be, it could be a web app, it could be a mobile app, it could even be the ChatGPT platform itself. Any application, any interface that would accept a user prompt, these are applications or environments that we can use to make this request. So the request would usually contain prompts. That is, when I say prompt, it's just technical, the sentence or your question or what you want to query the system about. And it would also contain the API credentials, and then it will contain some parameters like the response length or temperature. This is just like your structure, your prompt structure. So I would say at the application layer, you configure or design or construct your prompt structure, which would then be received by the Azure OpenAI. That is the second phase. At the Azure OpenAI, what happens there? Your request is received from the application layer. Then the Azure OpenAI would act as a gateway between your application and the AI model. So at this stage, you can define what model you want to work with. If it's going to be the GPT 4.0 or 5.2 charts, there are a lot of models in the Foundry that you can actually choose. So the Azure OpenAI here is bridging, standing as, it's representing a communication gateway between your application layer and that model. And this layer would undo the authentication, which is actually the checking for safety, the security layer in the non-technical diagram that we have on the left. So here is going to check out for the API authentication, it's going to check for the request validation, and it is going to check for communication with the Azure services. So practically, everything that has to do with security check happens at the OpenAI phase. Then next, the request is processed within the Azure Secure Cloud environment. What happens at this phase? Azure here would provide the networking information. It will provide the security controls. It will provide scalable computing resources. And then it will provide the monitoring and logging information. Your Azure Cloud infrastructure here, some organizations work with some custom cloud infrastructure, but still all embedded within the Azure Cloud services. At this stage, we have everything that has to do with looking towards the governance. If this request is actually following the proper rules, the proper policies, the proper security controls that has been laid down by the organization. Then next, it moves on to processing the language models. And here the request to be forwarded to the AI models, such as your GPT models or whatever models you want to work with in this case. Then the model will process the prompt, which has been collected from the application layer. And then at this stage, it will be working with the machine learning algorithm and generate a response. Then that moves on to the 6th layer, which is the response processing layer. And at this point here, before it sends back the response to the user who made the prompt, it has to do a formatting, does a double check to be sure that the response is actually correct, it is error free, and it is also it doesn't contain it doesn't contain words that are actually, for example, because with the Azure Open AI, you can actually check for some terminal words like offensive words. So it's going to do all of this check to be sure that the response is given out. It's a correct response, an error-free response, and a right response. And then finally, it returns that response to the user who prompts the request from the application layer. So in a non-technical view and from a technical view, this is what happens when an Azure Open AI is called. So it's pretty much a journey, but this is not something that is exposed to the physical eye or the front end or the end users. All they know is, they just prompt their web. Maybe they want to go to www.azure.com, and then in seconds, it returns their request to them. But in the background, all of these phases, all of these layers has been passed through. So what are the key components of Azure Open AI? We have just two basic components. We have the AI models, we have the GPT models. The AI models could be the GPT, the embedding models, and models that could actually incorporate text messages or images. We call them multimodal. And the second component is the API access, which actually helps communications with this application using the REST APIs. And an example of that is what I have here. So this is an example of what our post request looks like when a developer wants to interact with the application using the REST APIs. So these are just the basic two components of the Azure API, the Azure Open API, the AI models, and the API access. Then talking about security and governance, Azure Open AI integrates with the Azure Entra or the Microsoft Entra ID. It integrates with the role-based access control, and it also integrates with private networking. It integrates with compliance controls. And this is the reason why at the appropriate layer of its operation flow, it's able to check if the request that has been made at the application layer actually follows the security controls, the policies of that organization. It does a double check and also check if the person who has made the request has the right permission to access such information before it returns the response. Also, one can also detect harmful content, like I mentioned earlier, using the Azure Open AI. You can detect offensive text and policy violations with the Azure Open AI. So this is also an example of the end-to-end flow, which I explained earlier, right from the client application, which could be the app, the web, the chatbot, or any other interface that an end user can actually prompt switch. Then up down to the client's the phase where the client receives the AI response. So I'm going to move on to the next. And here, I will be mapping this. I'll be mapping this architecture with the AI assistants I'm currently working on. So so far so good on the AI assistants. I've actually worked with a couple of tools. I've worked with a Foundry. I've worked with VS Code. I've worked with the Azure Open AI itself. I've worked with GitHub, and then I've also worked with the Docker. So these are a few things that I'm able to pick up, because at a point, I think that was when I was trying to launch the back end. Let me see if I can pull up the okay. I have the application on the screen. Is that what you can see?
Yeah, we can see it's the Novartrax Cyber Skills Assistant.
Okay, yeah, that's good. All right, so basically with this with this solution, I quite learned a whole lot, because this is like the first solution I'm going to be building, having learned some skills. And you know, just like I said earlier, it's easier for me to put in hello, and I hit the send button, and it returns a welcome message for me, which is what I've actually configured it to be in the Azure Foundry while I was actually configuring the agent. Now, between the 2-3 seconds my hello was received and I get the response, all of the 7 layers has been passed through. All of those checks has been done before I was able to get the response. So this is a system that would be helping beginners, practically those who are just coming, transiting into cyber environments. They want to learn more about cyber security. They want to learn more about network security, cloud security, IAM, and more. And while learning, they also want to have like an instructor-led, a real-time experience. And that's the reason why this chatbot is here. I know that there are a lot of similar solutions that are already existing, but one thing I used to tell myself is it doesn't matter how many of it is existing. When I'm working on when I'm designing or building my solution, I'm going to make it as unique as I can, and having that experience is also a unique experience for me. So I don't actually believe in, oh, what you are doing, someone is doing it already, or it is existing already, then because of that, maybe I might feel like, oh, I don't want to work on this thing again, or I'm not going to be doing it again. No, I actually want to push and see how far I can go with it. So basically for this, I use the HTML, CSS, the JavaScript, and I used Python in designing the back end. And those are basically what I used while making up the solution. And the chat interface, which we can see on the screen here, is created with those tools that I mentioned. So it's just like having a flow. Let me see if I can pull up this. Okay, so how the chat interface works, we have the user would prompt the chat environment, and then all of the 7 layers, the prompt goes through all of the 7 layers and returns the response. So these are the tools that I worked with. With the web interface, which is the front interface, I worked with the HTML, the CSS, and JavaScript. Then for the backend, I worked with Python and I installed the Docker file. And also I have my Python file, HTML, the JS in the Docker container. Then I use the GPT 5.2 model to as my model. So I will take us through the Azure Foundry environment just to see what's so this is what my Foundry looks like. So I named my agents CyberSec GPT-5 2 chat, and so that's just pretty much what I did here. I have the Azure Open AI endpoint key, the API key, which I actually embedded in the .env file on my Visual Code Studio. And I was able to create some resources, the web app, the insights, which would monitor the application operations and also my container. And so right from here, although this is still a work in process, but this is just what I've done for now, and there are still lots to be done on this solution as I progress. So currently, for now, I launched with the Azure URL, and right from here, visiting the site, I have access to this. So what I learned in this is calling an Azure Open AI is just beyond, a call and response thing. It is a whole lot of process that goes in the background. And what are the 5 basic or 5 common mistakes that we need to avoid, that I did not avoid initially, and but I'm thankful to those mistakes, because when I ran into them with troubleshooting back and forth, I was able to learn more beyond what I imagined. I'm trying to bring up my okay. So one of the mistakes is calling an Azure Open AI directly from the front end. So this is one big mistake that we can make. I'm not talking about the experts now, but for those who are just coming into the AI environment, because the truth is, right now we have the artificial intelligence all over. There are a lot of expertise, a lot of specialists that would want to learn more about AI, start building solutions with AI, and of course, it's going to be a new domain, a new environment for them as well. So the reason why this is dangerous is because it exposes the API key and the Azure Open AI directly from the front end. It is also not it is not a security controlled practice, and it also allows users to bypass any safety rules that might have been incorporated, and it breaks the entire system architecture. So when we call or we try to call Azure Open AI directly from the front end, it is a dangerous practice which should be avoided. Another mistake is sending unstructured or messy prompts. Just like I mentioned earlier, I've seen a lot of people, that would always reach out to me that, okay, they are trying to use the chat GPT to do some research or to find out about some things, but it is not returning the right response to them, and they are confused. And then I discovered that most often times they really do not have the right or the proper structure to prompt this environment, because it's a tool, it is not human, so it would only work in the direction you want it to work. And so that's the reason why it is also important to ensure that when we are prompting at the application layer, we ensure that we have a structured prompt. Now, our structured prompts will define the keywords, the contents of what we want the Azure Open AI to return to us. If there is going to be paragraphs, we just have to make sure that our prompts are very well clear enough. Like, for example, now I might prompt and ask that okay, could you please guide me on how to install the .NET application? With that, it knows that, okay, it is going to give me a step-by-step guide, starting from the beginning to the end. And sometimes you can also prompt it to let it know our level of experience with what we are trying to learn about or query. So basically, that is one of the solution, the system I'm working on will be providing, because it's going to be a module structured learning environment where learners will have access to different modules for different courses, and there are assessments for every modules, and they can also have a real-time prompt. Unlike some other learning environments, maybe it could be a recorded session, or maybe some mostly recorded sessions, you know. And even on YouTube, sometimes when some of us are taking some learning courses, some videos on YouTube, we might run into confusion at a point, and then we pause the video, we reverse, we watch all over again. We may not really catch what the instructor is trying to point out. And at that point, you know, we pause the video and open another browser. We tend to put in our concern into the search engine that, okay, could you explain what this instructor is trying to teach here? Now, in that scenario, there is a possibility of the search engine not to return the expected response we want, because the search engine we are using does not have a direct visibility into that learning environment. So Novatrax has come to bridge that gap. It is an assistance that is embedded into the learning environment. So it has access into all the learning modules, and it is easier for it to connect to any learning module you want to prompt a question on, and it will return the right response. So here, sending a structured prompt is also a good practice. So we should avoid unstructured prompts when working with the Azure Open AI. Another error we should avoid is not handling errors gracefully. For example, when we have error connecting to backend. Error connecting to backend is one of the repetitive errors I experience while working on this system. And then I would discover that, oh, I didn't start the backend server. Then I have to go back to my Visual Studio Code. I'll restart the backend server, refresh it, and then go back to my fast API, which I'm using to test the front end, and it connects. And sometimes it could be an issue with my API key, because it actually took me a couple of days before I could figure out the right API key to use to work with. And in that couple of days, it was really a whole lot. But I'm happy I went through all of those times, because it's built me, and I'm able to figure out a lot of solutions. So there could be different causes to have the error connecting to backend error. One of the causes could be the backend not deployed or turned off. That was the case in my own. And another could be a wrong API URL. I also experienced that. It could be the cause issue or container slipping. So when I installed my Docker, there were days that it was already shut down. The engine was shut down. So I had to go restart it for me to have a successful backend activation. So here we have to be sure that the backend to the Azure Container App is properly deployed, and it is always running. What other mistakes should we avoid? Not using Azure Key Vault for secrets. So I also made this mistake because initially I had all my secrets. I had them I had my API key in my .env file on the Visual Studio, and I pushed this to GitHub. So at the point I had an issue, I had an error that there are sensitive information there and I cannot push them to a public environment, which is GitHub, because my GitHub was a public repository. So I had to use the git ignore to make sure that the .env file is, is taken off from the information that will be pushed to GitHub. And only at that time, I was able to have a successful push and pull and syncing. So hard coding API keys is a major security risk, and the architecture already supports key vaults. In our Azure environment, we have key vaults where we can have our secrets in the environment variables, and it helps to secure access. Another mistake we should avoid is not logging or monitoring OpenAI calls. We have the App Insight to help us monitor the health of our application. It would give us information about how the operation, how the application is performing, if users are having issues, if they're having challenges using the application. We have all of these logs when we have the App Insight. So it is important to work with the App Insight as well. Debug errors, improve prompts, track usage, and also detect abuse of that application. So in summary, when we call the Azure OpenAI, it is not a call it's not a plug and play operation. It has to go through 7 solid layers before we get our response. And this layers has to do with the networking, security, governance, orchestration, compute, and safety before a response is returned to the end user. So this would be all from me today. Observations, additions, questions, the floor is open. Thank you, Frank, for this opportunity, and thanks to everyone who has joined my session.
Very good. Excellent. And yeah, you really explained like that it is complicated, all right, in the background. There's a lot of things to connect up. So yeah, you must have had some job trying to get it all working. So any questions? Anybody? Looks like you're all good. I gave a talk there last year. It was 45 minutes, and there was 85 people in the room. It was in person, and I had 15 minutes for the Q&A, and I got 25 questions. So
Wow.
You're off the hook.
Have you found the MCT environments helpful?
Very, very, very helpful.
Yeah.
Very helpful. That's why I want to make the summit, because there's quite a number of people I want to meet physically.
Yeah, that's true.
Yeah.
The summit last year was really fun. It was my first time meeting Solomon. I had a chance after the summit to meet Opeyemi Stephen at LinkedIn in London. It was just a really, really cool experience, all in all.
Wow.
Yeah, so they were kind of just gone over time, so I'm just going to end the live stream. So thanks everyone for being here. You can still stay on the call, anybody that's there. I'll just thanks for joining us, and we'll be back here again next week at the same time with the Azure and AI show. So any comments on any of the speakers, send it into our LinkedIn, and we'll be happy to get a response to you. Thank you.
Thank you, Frank.
Thanks, Harry.
Yeah,
Thanks.
thank you, Dan. Thank you, Frank. Thank you, Opeyemi. Thank you, Ari.
Thank